Welcome to SciCuriousID, where we explore the fascinating mysteries of our world. Today, we delve into a phenomenon that challenges our very understanding of fire, cold fire. Imagine a fire that doesn't burn, a flame so cool you could touch it without harm. This might sound like something out of a fantasy novel or an ancient alchemist's dream, but it's a very real scientific marvel. Scientists have not only theorized about cold fire, but have successfully created and studied it in laboratories around the globe. This raises a profound question. Could cold fire truly exist? And if so, what makes it fundamentally different from the roaring infernos we typically associate with combustion?
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
The concept of a cold flame has captivated human imagination for centuries. From medieval legends speaking of eternal blue fires that never consumed their fuel, to intriguing 18th century experiments hinting at strange, low-temperature combustion, the idea has persisted. For much of history, our definition of fire was straightforward. It meant intense heat, visible light, and often destruction. It was a force to be respected, feared, and harnessed. However, in the early 1800s, pioneering chemists began to notice something peculiar. Certain fuels appeared to burn at temperatures so remarkably low that one could hold a metal wire in the flame without it glowing red hot. This observation challenged the conventional wisdom, suggesting that combustion wasn't always a violent, high-temperature event. It opened the door to understanding a different kind of burning. So, what's the science behind this intriguing phenomenon? Ordinary fire, like the familiar flicker of a candle flame, typically burns at around 1000 degrees Celsius. This intense heat and light are the direct result of rapid oxidation, where fuel molecules swiftly combine with oxygen, releasing a substantial amount of energy. However, if this oxidation reaction occurs slowly enough, the temperature simply doesn't rise high enough to produce those characteristic visible flames we're used to seeing. Instead, what you get is cold combustion, a process of oxidation that happens at much lower temperatures, typically ranging between 200 and 400 degrees Celsius. Cold fire, also known as a cool flame, is a special type of combustion where chemical reactions unfold in several slow, deliberate stages. These reactions release just enough energy to sustain themselves, creating a delicate balance, but not enough to generate roaring heat. The flame itself glows faintly, often appearing blue or violet, and can even extinguish itself if disturbed by a slight breeze. Cold flames are surprisingly common, occurring in places you might not expect, such as within the engines of our cars, in jet turbines, and even in the atmosphere of distant planets like Saturn's moon Titan. While often invisible to the naked eye, their presence can be detected through spectroscopy, which reveals the unique chemical signatures of reactions happening below normal ignition temperatures. In 2012, scientists aboard the International Space Station made an accidental, yet groundbreaking, discovery. While attempting to extinguish a droplet of fuel in microgravity, something extraordinary happened. Instead of simply going out, the fuel droplet began to burn in a completely new way, slow, perfectly spherical, and cold. The flame was nearly invisible, hovering like a ghost in the silent expanse of space. This accidental discovery has profound implications. Cold flames could revolutionize engine design, allowing engineers to create cleaner, more efficient engines that burn fuel more completely and release fewer pollutants. It's a phenomenon that might one day lead to truly greener combustion technology, significantly reducing our environmental footprint. Cold fire isn't magic, it's simply chemistry slowed down to a whisper. Unlike the roaring, destructive flames of a campfire, these reactions happen quietly, releasing their energy gently and controllably. It challenges our very definition of fire, demonstrating that burning doesn't always equate to intense heat or widespread destruction. It expands our understanding of fundamental processes, So, yes, cold fire does exist. It is a real, rare, and profoundly beautiful phenomenon. A flame that doesn't burn, yet still reminds us how mysterious and complex even the simplest elements can be. Stay curious, keep exploring, and join us again for more scientific wonders. Subscribe to SciCuriousID for more fascinating insights into the world around us.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.